You should definitely know these facts because they are very important for your knowledge. 100 facts about the moon. Please let us know in the comments where you are watching this video and what time you are watching it. And be sure to subscribe to the channel for future videos. Look up. On any clear night, no matter where you stand on the surface of this spinning, ancient Earth, there is one celestial companion that has been watching over humanity since the very first pair of eyes opened and gazed toward the heavens. It hangs there in the darkness, a luminous disk of silver and shadow, a lantern suspended in the infinite void, casting its pale glow across oceans, deserts, forests, and the sleeping faces of billions of souls. It has been called by 1,000 names in 1,000 languages. The Romans called it Luna, the Greeks knew it as Selene. In Sanskrit it is Chandra, in Arabic it is Al-Qamar, in Japanese it is Tsuki. But no matter what name humanity has given it, no matter what stories we have told about it, no matter what gods and goddesses we have associated with its silver face, it remains at its core one singular, extraordinary object, the moon. The moon is, without question, the most familiar celestial body in our sky. It is the first object beyond our own world that children learn to recognize. It is the subject of lullabies and love songs, of poetry and prayer, of myth and mathematics. It has guided sailors across treacherous seas. It has dictated the planting seasons of farmers for millennia. It has inspired artists, terrified the superstitious, and challenged the greatest scientific minds in human history. And yet, for all its familiarity, for all the centuries we have spent staring at its face, the moon remains a place of profound mystery, a world of contradictions and surprises, a celestial neighbor that we are only now, in the grand sweep of cosmic time, beginning to truly understand. In this documentary, we are going to take you on a journey to the moon and back, a journey through time and space, through science and history, through wonder and discovery. We are going to share with you 100 remarkable, astonishing, and deeply important facts about our closest cosmic companion. These are facts that will change the way you see that glowing orb in the night sky. These are facts that will deepen your understanding of the universe and your place within it. These are facts that, once you know them, you will never forget. So settle in, dim the lights, let the pale glow of the moon wash over your imagination, and let us begin. To understand the moon, we must first travel back in time, not merely centuries or millennia, but billions of years. We must journey to a moment so violent, so cataclysmic, so utterly world-shattering that it literally reshaped the destiny of our entire planet. We must go back approximately 4.5 billion years, to the earliest days of our solar system, when the Earth was young, molten, and still forming from the swirling disk of gas and dust that surrounded our newborn sun. In those ancient days, the solar system was a far more chaotic and dangerous place than it is today. Planets were still assembling themselves from the rubble of creation. Collisions were frequent. Massive bodies of rock and metal hurtled through space, crashing into one another with unimaginable force. And it was during this era of cosmic violence that something extraordinary happened, something that would give birth to our moon. Scientists believe that approximately 4.5 billion years ago, a body roughly the size of Mars, a protoplanet that has been given the name Theia, collided with the young Earth. This was not a glancing blow. This was not a gentle nudge. This was a full-scale, apocalyptic impact, an event so powerful that it is almost impossible for the human mind to comprehend. The energy released by this collision was billions of times greater than the most powerful nuclear weapon ever detonated. It was enough to melt the entire surface of the Earth, to vaporize vast quantities of rock, and to send an enormous plume of superheated debris spiraling out into space. This is known as the giant impact hypothesis, and it is the leading scientific explanation for how our moon came to exist. According to this theory, the debris ejected by the Theia impact did not simply fly off into the void and disappear. Instead, it was captured by Earth's gravity. It formed a ring of molten rock and vapor around our planet, a ring not unlike the rings of Saturn, but far more massive and far more turbulent. And over time, perhaps in as little as a few hundred years, perhaps over thousands, this ring of debris began to cool, to condense, and to coalesce. Piece by piece, fragment by fragment, the the scattered remnants of that ancient cataclysm came together to form a new world. A world of rock and dust, of craters and plains, of silence and shadow. The moon, think about that for a moment. The moon, that serene, peaceful, silver disk that floats so gracefully through our night sky, was born from an act of unimaginable violence. It is, in a very real sense, a child of destruction, a world forged in fire. And yet, without that destruction, without that ancient collision, the Earth as we know it would not exist. Life as we know it might never have arisen. The moon is not merely a companion to our planet. It is a vital part of who we are and how we came to be. But we will explore that extraordinary truth in much greater detail as our journey continues. Now let us talk about distance, because the relationship between the Earth and the moon is, in many ways, defined by the space that separates them. When you look up at the moon on a clear night, it appears close. It seems almost within reach, as though you could stretch out your hand and touch its glowing surface. But appearances, as they so often do, deceive. The moon orbits the Earth at an average distance of approximately 384,400 kilometers. That is roughly 238,900 miles. To put that in perspective, if you could drive a car at highway speed, say 100 kilometers per hour, and point it straight at the moon, it would take you approximately 160 days of non-stop driving to reach it. That is more than 5 months behind the wheel without stopping for fuel, food, or sleep. If you could walk to the moon at an average walking pace of about 5 kilometers per hour, the journey would take you nearly 9 years. And yet, in the context of the universe, this distance is almost laughably small. The moon is, by a vast margin, the closest significant celestial body to our planet. It is our nearest neighbor in space, and that proximity has had profound consequences for both worlds. The gravitational relationship between the Earth and the moon shapes our tides, stabilizes our planet's axial tilt, and influences the very rhythms of life on Earth. We are bound to the moon, and the moon is bound to us by invisible chains of gravity that have held us together for billions of years. But here is something truly remarkable about that distance: it is not constant. The moon is not locked in a perfectly circular orbit around the Earth. Its orbit is slightly elliptical, which means that sometimes it is closer to us and sometimes it is farther away. At its closest approach, known as perigee, the moon comes within approximately 356,500 kilometers of Earth. At its farthest point, known as apogee, it recedes to about 406,700 kilometers. This variation in distance is one of the reasons why the moon sometimes appears slightly larger or smaller in our sky, and it is the phenomenon that gives rise to what we commonly call a supermoon, a full moon that occurs when the moon is at or near its closest point to Earth, making it appear up to 14% larger and 30% brighter than a full moon at apogee. But the story of the moon's distance is even more fascinating than that, because the moon is not staying put. It is slowly, steadily, inexorably drifting away from us. Every single year, the moon moves approximately 3.8 centimeters farther from the Earth. That is roughly 1.5 inches per year. It may sound insignificant, and in human terms it is, but over the vast timescales of cosmic history, it adds up to an enormous change. When the moon first formed 4.5 billion years ago, it was much, much closer to the Earth than it is today. Some scientists estimate that the newly formed moon may have orbited at a distance of only about 22,500 kilometers, roughly 17 times closer than it is now. If you could travel back in time to those ancient days and look up at the sky, the moon would have appeared absolutely enormous, filling a vast portion of the heavens, a looming, terrifying presence that would have made our current moon look like a mere marble by comparison. This gradual recession of the moon is caused by the same force that creates our ocean tides, the gravitational interaction between the Earth and the moon. As the Earth rotates, it drags its tidal bulges slightly ahead of the moon. These bulges exert a gravitational pull on the moon, accelerating it slightly in its orbit. And as the moon gains energy, it moves to a higher orbit, farther from Earth. At the same time, the moon's gravity is gradually slowing down the Earth's rotation. Our days are getting longer, not by much, only about 2.3 milliseconds per century, but the effect is real and measurable. Billions of years ago, when the moon was much closer, the Earth spun much faster, and a day lasted only about 6 hours. The moon has literally been slowing us down, stretching our days, shaping the very passage of time on our planet for billions of years. Let us now turn our attention to the moon itself, to the world that waits out there in the darkness, 239,000 miles from where you sit right now. What kind of place is it? What would you find if you could somehow transport yourself to its surface? The first thing you would notice, and perhaps the most striking thing about the moon, is its size. Or rather, depending on your perspective, its lack of size. The moon is small. It has a diameter of approximately 3,474 kilometers, which makes it roughly 1/4 the diameter of Earth. If you place the moon next to the Earth, it would look like a tennis ball sitting beside a basketball. In terms of volume, you could fit about 49 moons inside the Earth. In terms of mass, the moon weighs in at approximately 73.5 billion trillion kilograms, which sounds like an enormous number, but it is actually only about 1.2% of Earth's mass. And yet, despite its relatively modest size, the moon holds a rather distinguished position in our solar system. It is the 5th largest natural satellite, the 5th largest moon in the entire solar system. Only Jupiter's moons Ganymede, Callisto, and Io, and Saturn's moon Titan are larger. And when you consider the size of the moon relative to the planet it orbits, it becomes truly exceptional. The moon is about 1/4 the diameter of Earth, making it by far the largest moon relative to its host planet of any of the rocky inner planets. In fact, the Earth-Moon system is sometimes described not as a planet and its satellite, but as a double planet, two worlds orbiting a common center of gravity, locked in an eternal gravitational embrace. Now, if you were to stand on the surface of the moon and look around, you would find yourself in one of the most alien, most desolate, and most hauntingly beautiful landscapes in the known universe. The surface of the moon is covered in a layer of fine, powdery material called regolith. This is not soil in the way we understand it on Earth. There are no organic components, no microbes, no nutrients. It is a blanket of crushed rock, shattered by billions of years of meteorite impacts, baked by unfiltered solar radiation, and ground into a fine, abrasive powder that clings to everything it touches. The Apollo astronauts who walked on the moon described the regolith as having the consistency of talcum powder or wet sand, and they noted that it had a distinct smell, a smell they compared to spent gunpowder or burnt charcoal. This smell is thought to be caused by the chemical reaction that occurs when the regolith, which contains minerals that have been altered by exposure to the solar wind, comes into contact with the moist air inside the lunar module. The lunar regolith varies in depth across the surface of the moon. In the Highland regions, it can be up to 20 meters deep. In the younger mare regions, the dark, flat plains that are visible from Earth, it may be only a few meters thick. Beneath the regolith lies a layer of fractured bedrock called the megaregolith, which extends down several kilometers, and beneath that lies the solid crust of the moon itself. The surface of the moon is dominated by two primary types of terrain. The first and most visually striking from Earth are the dark, smooth plains known as maria, a Latin word meaning seas. When the earliest astronomers looked at the moon through their primitive telescopes, they saw these dark patches and assumed they were bodies of water, oceans, and seas on the lunar surface. They gave them evocative names: the Sea of Tranquility, the Ocean of Storms, the Sea of Serenity, the Sea of Crises, the Bay of Rainbows. Of course, we now know that these are not seas at all. They are vast plains of solidified basaltic lava, created by ancient volcanic eruptions that flooded enormous impact basins billions of years ago. The maria are among the youngest features on the lunar surface, with ages ranging from about 3 to 3.5 billion years, and they cover approximately 16% of the moon's total surface area. Interestingly, almost all of the maria are found on the near side of the moon, the side that faces Earth. The far side, which we will discuss in much greater detail later, is almost entirely composed of the other primary terrain type, That other terrain type is the lunar highlands. These are the bright, rugged, heavily cratered regions that make up the majority of the moon's surface. The highlands are older than the Maria, much older, with some regions dating back nearly 4.5 billion years to the earliest days of the moon's existence. They are composed primarily of a light-colored rock called anorthosite, which is rich in the mineral plagioclase feldspar. The highlands stand higher in elevation than the Maria, which is why they appear brighter, they reflect more sunlight, and they are absolutely covered in craters. Craters upon craters upon craters, overlapping and intersecting, a record of billions of years of cosmic bombardment written in stone and shadow. Speaking of craters, the moon is one of the most heavily cratered bodies in the solar system, and its craters tell a story that spans the entire history of our cosmic neighborhood. Unlike the Earth, the moon has no atmosphere to burn up incoming meteorites, no weather to erode its surface, no tectonic activity to recycle its crust. Every impact that has ever occurred on the moon has left its mark, and those marks are preserved with astonishing fidelity, like footprints in stone. The moon's surface is, in a very real sense, a museum of cosmic violence, a record of every collision that has occurred in the inner solar system over the past 4.5 billion years. The craters on the moon range in size from tiny pits only a fraction of a millimeter across, created by the impact of micrometeorites, to enormous basins hundreds of kilometers in diameter, gouged out by the impact of asteroids the size of small mountains. The largest confirmed impact structure on the moon is the South Pole Aitken Basin, located on the far side of the moon near the lunar South Pole. This colossal scar is approximately 2,500 kilometers in diameter and about 8 kilometers deep, making it one of the largest known impact structures in the entire solar system. It was created by a cataclysmic impact that occurred approximately 4.3 billion years ago, and it is so large that it would stretch from New York to Los Angeles if placed on the surface of the Earth. But the craters that most people are familiar with, the craters that are visible through even a modest backyard telescope, are the named craters that dot the near side of the moon. Craters like Tycho, with its spectacular system of bright rays that stretch across the lunar surface like the spokes of a wheel, evidence of the tremendous energy released by the impact that created it approximately 108 million years ago. Craters like Copernicus, a stunning, terraced impact structure 93 kilometers wide, with a complex system of central peaks formed by the rebound of the crater floor after the impact. Craters like Clavius, one of the largest craters visible from Earth, 131 miles in diameter, with smaller craters dotting its floor in a diminishing sequence that has delighted lunar observers for centuries. Each of these craters is a time capsule, a frozen moment of cosmic violence, and together, they form a chronological record that scientists have used to piece together the history of the inner solar system. By studying the density and distribution of craters on different parts of the lunar surface, researchers have been able to determine the relative ages of various regions and to reconstruct the timeline of bombardment that shaped the moon, and by extension the Earth, during its formative years. One of the most significant discoveries to emerge from this crater counting technique is the concept of the late heavy bombardment, also known as the lunar cataclysm. This was a period approximately 3.9 to 4.1 billion years ago during which the inner solar system experienced a dramatic spike in the rate of asteroid and comet impacts. The evidence for this event comes primarily from the moon, where many of the largest impact basins, including the Imbrium, Serenitatis, and Crisium basins, appear to have formed during this relatively narrow window of time. If the late heavy bombardment did occur, and the idea remains the subject of vigorous scientific debate, it would have had profound implications for the early Earth as well, potentially sterilizing the planet's surface and delaying the emergence of life. Or paradoxically, it may have delivered the very water and organic molecules that would eventually give rise to life. The moon, silent and patient, holds the evidence that may one day allow us to answer this profound question. Now let us talk about something that has puzzled and fascinated humanity for as long as we have looked up at the night sky, the face of the moon. The way it always shows us the same side, the way we never see its back. This phenomenon is called tidal locking or synchronous rotation, and it is one of the most elegant and important facts about our lunar companion. The moon rotates on its axis at exactly the same rate that it orbits the Earth. One complete rotation takes approximately 27.3 days. One complete orbit also takes approximately 27.3 days. The result of this precise synchronization is that the same hemisphere of the moon always faces the Earth. We see the same craters, the same maria, the same patterns of light and shadow, night after night, year after year, century after century. The far side of the moon, often mistakenly called the dark side, remained completely unseen by human eyes until October of 1959, when the Soviet spacecraft Luna 3 flew behind the moon and took the first grainy, ghostly photographs of the hidden hemisphere. This tidal locking is not a coincidence. It is the result of billions of years of gravitational interaction between the Earth and the moon. In the early days of the Earth-Moon system, the moon rotated much faster than it does today. But the Earth's gravitational pull created tidal forces within the moon, not ocean tides, since the moon has no oceans, but tidal bulges in its solid rock. These bulges acted as a brake on the moon's rotation, gradually slowing it down until its rotational period matched its orbital period. Once this synchronization was achieved, the system reached a state of equilibrium, and the moon's rotation has remained locked ever since. It is important to understand that tidal locking does not mean that the far side of the moon is permanently dark. The far side receives just as much sunlight as the near side. Every part of the moon experiences approximately 2 weeks of continuous daylight followed by approximately 2 weeks of continuous darkness. The term dark side is a misnomer that probably originated from the fact that this hemisphere was hidden from our view, dark in the sense of unknown, not in the sense of unlit. When humanity finally did get a look at the far side of the moon, what we found was astonishing. The far side looks dramatically different from the near side. While the near side is dominated by the dark, smooth maria, those ancient lava plains, the far side is almost entirely covered in bright, rugged, heavily cratered highland terrain. There are very few maria on the far side. The contrast is so stark that the two hemispheres almost look like different worlds. Scientists are still debating the reasons for this dramatic asymmetry. One leading theory suggests that the crust on the far side is thicker than the crust on the near side, making it more difficult for magma from the interior to break through and flood the surface. This difference in crustal thickness may be related to the moon's formation and early thermal history. Another theory proposes that the near side received more heat from the nearby Earth in the moon's early days, which kept its crust thinner and more prone to volcanic activity. Whatever the explanation, the dichotomy between the near and far sides of the moon remains one of the most intriguing mysteries in lunar science. Let us now consider what lies beneath the moon's battered surface, because the moon, like the Earth, has an internal structure, layers of material that tell us about how it formed and how it has evolved over the course of its long history. The moon has a layered interior consisting of a crust, a mantle, and a core, similar in broad structure to the Earth, but very different in detail. The lunar crust is its outermost layer, and it varies significantly in thickness between the near side and the far side. On the near side, the crust is approximately 60 kilometers thick. On the far side, it may be as thick as 100 kilometers. This asymmetry, as we just discussed, likely plays a role in the dramatic visual differences between the two hemispheres. Beneath the crust lies the mantle, which makes up the bulk of the moon's interior. The lunar mantle is composed primarily of silicate minerals rich in iron and magnesium, similar to the minerals found in Earth's mantle, but with some important differences in composition. The upper mantle is relatively rigid, while the lower mantle may be partially molten or at least plastic enough to flow slowly over geological timescales. At the very center of the moon lies its core. For many years, the nature and size of the moon's core was the subject of considerable uncertainty. But data from the Apollo seismometers, instruments left on the lunar surface by astronaut crews in the late 1960s and early 1970s, combined with more recent observations from orbiting spacecraft, have given us a much clearer picture. The moon has a small, dense core with a radius of approximately 350 kilometers. This core is composed primarily of iron, and it appears to have both a solid inner component and a fluid outer component, similar in structure to Earth's core but much smaller in proportion to the moon's overall size. The moon's core makes up only about 20% of its radius, compared to about 50% for Earth. The small size of the moon's core is one of the key pieces of evidence supporting the giant impact hypothesis for the moon's formation. When Theia struck the early Earth, the collision is thought to have primarily ejected material from the outer layers of both bodies, their mantles and crusts, while most of their dense, iron-rich cores merged and remained with the Earth. This would explain why the moon is so depleted in iron compared to the Earth, and why its core is proportionally so small. The moon's small core also explains one of the most notable differences between the moon and the Earth, the moon's lack of a global magnetic field. The Earth's magnetic field is generated by the churning motion of molten iron in its outer core, a process known as a dynamo. The moon's core is too small and too cool to sustain an active dynamo today, so the moon has no significant global magnetic field. However, this was not always the case. Studies of lunar rocks brought back by the Apollo missions have revealed that many of them are magnetized, indicating that the moon did once possess a magnetic field. This ancient lunar dynamo appears to have been active from at least 4.2 billion years ago until sometime between 1 and 2.5 billion years ago. The reasons for its eventual cessation are still being studied, but the loss of the moon's magnetic field had significant consequences for its surface environment, leaving it exposed to the full force of the solar wind and cosmic radiation, a topic we will explore later. Now let us talk about gravity, because gravity on the moon is one of the most fundamental ways in which it differs from our own world, and it has profound implications for everything from the behavior of objects on the lunar surface to the way astronauts move and work. The gravitational pull on the surface of the moon is approximately 1/6 that of Earth. To be precise, the gravitational acceleration on the moon's surface is about 1.62 meters per second squared, compared to 9.81 meters per second squared on Earth. This means that if you weigh 180 pounds on Earth, you would weigh only 30 pounds on the moon. You would feel light, buoyant, almost ethereal. You could jump 6 times higher than you can on Earth. You could lift objects that would be impossibly heavy in terrestrial gravity. The Apollo astronauts experienced this firsthand, and their descriptions of moving in lunar gravity are among the most vivid and memorable accounts of the entire space program. They described a bouncing, loping gait that was unlike anything they had experienced in training. They found that the best way to move across the lunar surface was not to walk normally, but to adopt a kind of skipping motion, bounding from one foot to the other in long, lazy arcs. Neil Armstrong and Buzz Aldrin, during the first moonwalk in July of 1969, experimented with various modes of locomotion and discovered that this kangaroo-like hop was the most efficient and stable way to traverse the dusty terrain. Later Apollo missions, equipped with the lunar roving vehicle, allowed astronauts to cover much greater distances, but even in the rover, the effects of reduced gravity were apparent. The vehicle would bounce and skip over the surface, its wheels occasionally leaving the ground entirely as it traversed uneven terrain. The moon's low gravity has other important consequences as well. It is one of the reasons why the moon has essentially no atmosphere. A body's ability to retain an atmosphere depends on its gravity and its temperature. The moon's weak gravitational pull means that gas molecules moving at even moderate speeds can easily reach escape velocity and fly off into space. Over billions of years, any atmosphere the moon may have once possessed has been stripped away, molecule by molecule, leaving behind a vacuum so near perfect that it is actually better than most vacuums we can create in laboratories on Earth. Well, that is not entirely accurate. The Moon does have what scientists call an exosphere, an incredibly thin, tenuous envelope of gas that barely qualifies as an atmosphere by any conventional definition. The total mass of the Moon's exosphere is estimated at only about 25,000 kilograms, about the weight of a few large trucks. By comparison, Earth's atmosphere has a mass of approximately 5.1 quintillion kilograms. The lunar exosphere is composed of atoms and molecules of various gases, including helium, neon, argon, sodium, and potassium, among others. These gases come from several sources. Some are released from the lunar soil by solar radiation, some are delivered by the solar wind, and some are produced by the radioactive decay of elements within the Moon's interior. The exosphere is so thin that the individual atoms and molecules in it are more likely to collide with the surface of the Moon than with each other, a condition known as a surface boundary exosphere. The practical consequence of the Moon's lack of a substantial atmosphere is profound. There is no weather on the Moon, no wind, no rain, no clouds, no storms. There is no sound because sound requires a medium air to propagate as pressure waves, and in the near vacuum of the Moon there is simply nothing for sound waves to travel through. If you stood on the surface of the Moon and screamed at the top of your lungs, no one standing next to you would hear a thing unless you were both connected by radio. The silence of the Moon is absolute and eternal. The absence of an atmosphere also means there is no protection from the hazards of space. On Earth, our atmosphere acts as a shield blocking harmful ultraviolet radiation from the sun, absorbing and deflecting micrometeorites, and trapping heat to maintain a relatively stable surface temperature. The Moon has none of these protections. Solar radiation strikes the lunar surface with full, unattenuated force. Micrometeorites, tiny particles of space dust traveling at speeds of up to 70 kilometers per second, slam into the surface constantly, gradually grinding down the rocks and contributing to the ever-growing layer of regolith. And the solar wind, a stream of charged particles flowing outward from the sun, washes over the Moon continuously, implanting itself into the surface material and altering its chemical composition over billions of years. This brings us to one of the most dramatic and extreme characteristics of the lunar environment, its temperature. Without an atmosphere to moderate heat transfer, the Moon's surface experiences temperature swings that are almost beyond comprehension. During the lunar day, when a given spot on the surface is exposed to direct sunlight for approximately 2 weeks, temperatures can soar to approximately 127 degrees Celsius, that is 260 degrees Fahrenheit, hot enough to boil water. During the lunar night, when the same spot is plunged into darkness for another 2 weeks, temperatures plummet to approximately minus 173 degrees Celsius, that is minus 280 degrees Fahrenheit, cold enough to freeze and shatter most materials. The temperature difference between lunar day and lunar night is roughly 300 degrees Celsius, a swing that would be instantly lethal to any unprotected human being. These extreme temperatures present enormous challenges for both human exploration and robotic missions. Spacecraft and equipment must be designed to withstand both scorching heat and bone-cracking cold, often within the same mission. The Apollo astronauts were protected by their spacesuits, which were engineering marvels designed to maintain a comfortable internal temperature regardless of external conditions. But even with this protection, the astronauts reported feeling the heat of the sun through their suits and noticing the rapid cooling that occurred when they stepped into shadow. Interestingly, there are places on the Moon where these temperature extremes are even more pronounced, and places where they are remarkably moderate. At the lunar poles, particularly at the South Pole, there are deep craters whose floors never see sunlight. These permanently shadowed regions are among the coldest places in the entire solar system, with temperatures dropping below minus 240 degrees Celsius, colder than the surface of Pluto. In these frigid, lightless depths, something extraordinary has been discovered, something that could change the future of human space exploration. But we are getting ahead of ourselves. We will return to that discovery shortly. Let us first take a moment to appreciate something that many people take for granted, but that is, in fact, one of the most remarkable coincidences in all of astronomy: the apparent size of the moon in our sky compared to the apparent size of the sun. The sun is approximately 400 times larger than the moon in diameter. But here is the astonishing thing: the sun is also approximately 400 times farther away from Earth than the moon. These two facts combine to create one of the most spectacular phenomena in all of nature: total solar eclipses. Because the sun and the moon appear almost exactly the same size in our sky, each covering about half a degree of arc, the moon is able to almost perfectly block the sun during a total solar eclipse, covering the brilliant solar disk and revealing the sun's ethereal corona, its outer atmosphere, which is normally invisible to the naked eye. This is an extraordinary cosmic coincidence. There is no physical reason why the sun and the moon should appear the same size in our sky. It is not a consequence of any fundamental law of physics. It is simply a happy accident of geometry, a coincidence of distance and diameter that exists at this particular moment in the history of the Earth-Moon system, and it will not last forever. Because the moon is slowly moving away from the Earth, it is gradually appearing smaller in our sky. In the distant future, roughly 600 million years from now, the moon will have receded far enough that it will no longer be large enough to completely cover the sun. Total solar eclipses will become a thing of the past. We are living in a cosmically privileged time, the only era in which total solar eclipses are possible from the surface of our planet. Total solar eclipses have played a remarkably important role in the history of science. During the total solar eclipse of May 29, 1919, the British astronomer Arthur Eddington led expeditions to the island of Principe off the coast of West Africa and to Sobral in Brazil to photograph stars near the sun during totality. The goal was to test Albert Einstein's general theory of relativity, which predicted that the sun's gravity would bend the path of starlight passing near it, causing stars close to the sun to appear slightly shifted from their normal positions. Eddington's observations confirmed Einstein's prediction, providing one of the first experimental verifications of general relativity and making Einstein an international celebrity overnight. And this groundbreaking scientific achievement was only possible because the moon happens to be just the right size and just the right distance to perfectly block the sun. The moon, in a very real sense, helped us confirm one of the most important theories in the history of physics. Now let us turn to a topic that touches every corner of our planet and affects every living thing on Earth: the tides. The ocean tides are one of the most visible and tangible effects of the moon's gravitational influence on our world, and they are far more complex, far more important, and far more fascinating than most people realize. The tides are caused primarily by the gravitational pull of the moon on the Earth's oceans. The moon's gravity pulls on the water on the side of the Earth closest to it, creating a bulge of water, a high tide on that side. At the same time, on the opposite side of the Earth, the water bulges outward as well, because the moon's gravitational pull is weaker there, and the water is, in a sense, being left behind as the solid Earth beneath it is pulled toward the moon. The result is that there are two high tides and two low tides approximately every 24 hours and 50 minutes, the time it takes for a given point on Earth to rotate back to the same position relative to the moon. The sun also contributes to the tides, but its effect is about half as strong as the moon's, despite the sun being vastly more massive. This is because tidal forces depend not only on mass but also on distance, specifically on the cube of the distance. The sun is so much farther away than the moon that its tidal influence is correspondingly reduced. When the sun, Earth, and moon are aligned during full moons and new moons, the solar and lunar tidal forces combine to produce especially high tides and especially low tides, known as spring tides. When the sun and moon are at right angles relative to the Earth during the first and third quarter moons, their tidal forces partially cancel each other out, producing moderate tides known as neap tides. The tides have had a profound influence on the development of life on Earth. The intertidal zone, the strip of coastline that is alternately submerged and exposed by the tides, is one of the most dynamic and ecologically productive habitats on the planet. Some scientists have even speculated that the tidal zone may have played a crucial role in the transition from aquatic life to terrestrial life, providing a natural laboratory where organisms were repeatedly exposed to air and water, driving the evolutionary adaptations that eventually allowed life to colonize the land. If this theory is correct, then the Moon, through its gravitational influence on Earth's oceans, may have been a key factor in the emergence of complex terrestrial life, including, ultimately, us. The tidal interaction between the Earth and the Moon also has another profound consequence that we touched on earlier: the gradual slowing of Earth's rotation. The tidal bulges on Earth act as a kind of brake, and the friction between the moving water and the solid Earth beneath it dissipates rotational energy. Over geological time, this has dramatically slowed the Earth's spin. 4.5 billion years ago, when the Moon was much closer and its tidal forces were much stronger, the Earth may have been rotating so fast that a day lasted only about 4 to 6 hours. The tides have steadily, patiently, relentlessly slowed us down, stretching our days from those brief 4-hour rotations to the 24-hour days we enjoy today, and the process continues. Our days are still getting longer, imperceptibly but inexorably, by about 2.3 milliseconds per century. Let us now talk about one of the Moon's most important contributions to the stability of life on Earth, a contribution that is often overlooked, but that may be the single most significant thing the Moon does for our planet. The Moon stabilizes the tilt of Earth's axis. The Earth's axis is tilted at approximately 23.5 degrees relative to its orbital plane around the Sun. This tilt is what gives us our seasons: summer and winter, spring and fall. Without this tilt, there would be no seasons, and the climate of the Earth would be radically different. But here's the crucial point: without the Moon, the Earth's axial tilt would not remain stable. It would wobble chaotically, swinging between extreme values over periods of millions of years. Mars, which has no large moon to stabilize it, has experienced exactly this kind of chaotic axial variation, with its tilt swinging from near zero to more than 60 degrees over the course of its history. If the Earth's axial tilt were to vary so dramatically, the consequences for life would be catastrophic. Extreme tilts would produce extreme seasons, periods of perpetual sunlight at the poles followed by perpetual darkness, scorching summers followed by brutal winters, wild swings in temperature and weather that would make it extremely difficult for complex life to adapt and survive. The Moon's gravitational influence prevents this from happening. It acts as a stabilizer, a cosmic gyroscope, keeping the Earth's axial tilt within a relatively narrow range, between about 22.1 degrees and 24.5 degrees, over a cycle of approximately 41,000 years. This stability has persisted for billions of years, providing the consistent, predictable climate patterns that have allowed complex life to evolve and thrive on our planet. Think about that for a moment. Without the Moon, the Earth's climate would be chaotic and unpredictable. Complex life might never have evolved. Human civilization might never have arisen. The very fact that you are sitting here right now, watching this documentary, living your life on a planet with stable seasons and a hospitable climate, may be directly attributable to the presence of that silver disk in the sky. The Moon is not merely a pretty face in our night sky. It is a guardian, a stabilizer. A cosmic anchor that has quietly, invisibly, and faithfully protected the conditions for life on Earth for billions of years. Now let us journey to one of the most thrilling chapters in the entire history of human civilization, the exploration of the Moon. For as long as humans have existed, we have dreamed of traveling to the Moon. We have imagined it, written about it, sung about it, prayed to it. And in the 20th century, in one of the most audacious and extraordinary achievements in the history of our species, we finally did it. We went to the Moon, and we walked upon its surface. The story of humanity's journey to the Moon is, in many ways, the story of the Cold War, the decades-long geopolitical struggle between the United States and the Soviet Union that dominated the second half of the 20th century. Both superpowers saw space as the ultimate frontier, the ultimate proving ground for their competing ideologies and technological capabilities, and the moon was the ultimate prize. The Soviet Union struck first. On January 2, 1959, the Soviet spacecraft Luna 1 became the first human-made object to fly past the moon, passing within about 6,000 kilometers of the lunar surface. Later that same year, on September 14th, Luna 2 became the first human-made object to reach the surface of another celestial body when it deliberately crashed into the moon. And just 1 month after that, on October 7th, Luna 3 looped around the far side of the moon and took the first photographs of the hemisphere that had been hidden from human eyes since the dawn of consciousness. These Soviet achievements sent shockwaves through the United States. The Americans were losing the space race, and they knew it. On May 25, 1961, President John F. Kennedy stood before a joint session of Congress and delivered one of the most famous speeches in American history. "I believe," he said, "that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth." It was a breathtakingly audacious challenge. At the time Kennedy made this declaration, the United States had exactly 15 minutes of human spaceflight experience, a single suborbital flight by Alan Shepard just 3 weeks earlier. The idea of landing astronauts on the moon within 9 years seemed, to many observers, somewhere between wildly optimistic and completely insane. But the United States committed itself to this goal with a determination and intensity that remains unmatched in the history of peacetime technological endeavor. The Apollo program was born, and it would become one of the most ambitious, most expensive, and most successful projects ever undertaken by human beings. The path to the moon was not smooth. It was paved with setbacks, failures, and tragedy. On January 27, 1967, astronauts Gus Grissom, Ed White, and Roger Chaffee were killed when a fire broke out in the Apollo 1 command module during a launch pad test. The pure oxygen atmosphere inside the capsule turned a small electrical spark into an inferno, and the astronauts were unable to escape. The Apollo 1 fire was a devastating blow to the program, and it led to a comprehensive redesign of the spacecraft and a renewed commitment to safety. But the program pressed on. Apollo missions tested the hardware in Earth orbit and in lunar orbit, building confidence and experience with each flight. Apollo 7 tested the redesigned command module in Earth orbit. Apollo 8 in December of 1968 became the first manned spacecraft to orbit the moon, carrying astronauts Frank Borman, Jim Lovell, and Bill Anders on a breathtaking journey around the far side. It was during Apollo 8 that one of the most iconic photographs in history was taken, Earthrise, showing our small, blue, fragile planet rising above the desolate lunar horizon. That single image is widely credited with helping to launch the environmental movement, giving humanity its first truly visceral sense of the beauty and vulnerability of our home world. Apollo 9 and Apollo 10 tested the lunar module, the spidery, ungainly spacecraft that would actually carry astronauts down to the lunar surface and back. Apollo 10 was a full-dress rehearsal for the landing, with astronauts Tom Stafford and Gene Cernan descending to within about 15 kilometers of the lunar surface before returning to the command module. Everything was ready, and then came Apollo 11. On July 16, 1969, a Saturn V rocket, the most powerful machine ever built by human hands, standing 363 feet tall and generating 7.5 million pounds of thrust, lifted off from Launch Complex 39A at Kennedy Space Center in Florida. Aboard were 3 astronauts, Neil Armstrong, Edwin Buzz Aldrin, and Michael Collins. Their destination was the Sea of Tranquility. Their mission was to land on the moon. 3 days later, on July 20th, after a journey of approximately 240,000 miles, Armstrong and Aldrin separated from the command module Columbia, which Collins would continue to pilot in lunar orbit, and began their descent to the surface in the lunar module Eagle. The descent was harrowing. Alarms sounded in the cockpit, computer overload warnings that momentarily threatened to abort the mission. Armstrong, looking out the window, saw that the computer was guiding them toward a boulder-strewn crater, and he took manual control, flying the lander past the hazard and searching for a safe landing spot. Fuel was running dangerously low. Mission control in Houston listened, tense and silent, as the fuel gauge ticked down. 25 seconds of fuel remaining, then 15. Then finally, at 4:17 p.m. Eastern Daylight Time on July 20th, 1969, a light on the instrument panel illuminated, indicating that a probe extending from one of Eagle's landing legs had touched the surface. Armstrong's voice crackled through the static. "Houston, Tranquility Base here. The Eagle has landed." 6.5 hours later, at 10:56 p.m., Neil Armstrong descended the ladder of the lunar module and placed his left foot on the surface of the moon. "That's one small step for man," he said, "one giant leap for mankind." With those words broadcast live to an estimated 530 million people watching on television around the world, roughly 1/7 of the entire human population at the time, a new chapter in the story of our species was opened. For the first time in 4.5 billion years of history, a living creature born on Earth stood on the surface of another world. Buzz Aldrin joined Armstrong on the surface about 20 minutes later. Together, they spent approximately 2 hours and 31 minutes outside the lunar module, during which they planted an American flag, collected lunar soil and rock samples, deployed several scientific instruments, took photographs, and made observations. Aldrin famously described the lunar landscape as magnificent desolation. Armstrong and Aldrin left behind a plaque on the leg of the lunar module's descent stage that read, "Here men from the planet Earth first set foot upon the moon, July 1969, AD we came in peace for all mankind." The success of Apollo 11 was followed by 5 more successful lunar landings over the next 3.5 years. Apollo 12 landed in the Ocean of Storms in November of 1969, demonstrating precision landing capability by touching down within walking distance of the Surveyor 3 probe, which had been sitting on the moon since 1967. The astronauts actually retrieved pieces of Surveyor 3 and brought them back to Earth for study. Apollo 13, launched in April of 1970, is perhaps the most famous of all the Apollo missions, not for what it achieved on the moon, because it never landed, but for the extraordinary drama of its near disaster and miraculous rescue. An oxygen tank in the service module exploded approximately 56 hours into the mission, crippling the spacecraft and putting the lives of astronauts Jim Lovell, Jack Swigert, and Fred Hayes in grave danger. Using the lunar module as a lifeboat and employing a series of brilliant improvisations by both the crew and mission control, the astronauts managed to loop around the moon and return safely to Earth. Apollo 13 is often described as NASA's finest hour, not because of the things that went right, but because of the way the agency responded when everything went wrong. Apollo 14 landed in the Fra Mauro Highlands in February of 1971, with Alan Shepard, America's first man in space, commanding the mission. Shepard, in one of the most memorable moments of the entire Apollo program, brought 2 golf balls and a makeshift 6-iron to the moon and hit them across the dusty surface, declaring that the second ball went miles and miles and miles. In the low lunar gravity, the balls sailed much farther than they would have on Earth, though probably not quite as far as Shepard claimed. Apollo 15, launched in July of 1971, marked a significant expansion in the scope of lunar exploration. It was the first of the J missions, which carried greater scientific payloads, stayed on the surface longer, and most notably, carried the Lunar Roving Vehicle, an electric-powered buggy that allowed astronauts to explore much larger areas of the lunar surface than had been possible on foot. Apollo 15 landed near Hadley Rill, a sinuous channel on the edge of the Apennine Mountains, and the stunning footage of astronauts David Scott and James Irwin driving across the lunar landscape remains some of the most breathtaking imagery ever captured. Apollo 16 landed in the Descartes Highlands in April of 1972, becoming the first mission to explore a highland region and providing crucial samples of the ancient lunar crust. And finally, Apollo 17 in December of 1972 marked the last time, to date, that human beings walked on the surface of another world. Commander Eugene Cernan and lunar module pilot Harrison Schmitt, a trained geologist and the only scientist to walk on the moon, spent over 22 hours outside their spacecraft during 3 separate moonwalks, covering more than 35 kilometers in the lunar roving vehicle and collecting approximately 110 kilograms of lunar samples. As Cernan climbed back into the lunar module for the last time, he spoke words that have echoed through the decades. "As I take man's last step from the surface, back home for some time to come, but we believe not too long into the future, I'd like to just say what I believe history will record, that America's challenge of today has forged man's destiny of tomorrow." In total, 12 human beings have walked on the surface of the moon, all of them American, all of them men, and all of them between 1969 and 1972. They spent a combined total of approximately 80 hours walking and working on the lunar surface. They drove a combined distance of approximately 90 kilometers in the lunar roving vehicle. They collected approximately 382 kilograms, 842 pounds, of lunar rock and soil samples, which remain the most valuable and scientifically important collection of extraterrestrial material on Earth. And they left behind an assortment of equipment, instruments, flags, plaques, family photographs, and in the case of Apollo 15 Commander David Scott, a small aluminum figurine called the Fallen Astronaut, placed on the lunar surface along with a plaque listing the names of 14 astronauts and cosmonauts who had died in the pursuit of space exploration. The Apollo program cost approximately $25.4 billion, equivalent to roughly $200 billion in today's money, and at its peak, it employed approximately 400,000 people across 20,000 companies and universities. It remains, by almost any measure, one of the greatest achievements in the history of human civilization, and it was all driven by a desire to reach that silver disk in the sky, our moon. But the Apollo astronauts did not merely visit the moon, they also fundamentally transformed our scientific understanding of it. The lunar samples they brought back have been studied continuously for over 50 years, and they have yielded an extraordinary wealth of knowledge about the moon's composition, history, and origin. One of the most important findings from the Apollo samples is that the rocks on the moon are remarkably similar in composition to rocks on Earth, particularly in terms of their oxygen isotope ratios. This is powerful evidence in support of the giant impact hypothesis, because it suggests that the moon formed primarily from material that originated on Earth, or at least from a body that shared Earth's oxygen isotope signature. The Apollo samples also revealed that the moon is extremely dry, far drier than any rock on Earth, and depleted in volatile elements, which is consistent with a formation scenario involving extreme heat. The rocks show no evidence of having ever been in contact with water, and they contain no organic material whatsoever. The Apollo missions also deployed a network of scientific instruments on the lunar surface, collectively known as the Apollo Lunar Surface Experiments Package, or ALSCP. These instruments included seismometers to detect moonquakes, magnetometers to measure the lunar magnetic field, heat flow probes to measure the temperature gradient beneath the surface, laser retroreflectors to enable precise measurements of the Earth-Moon distance, and various particle detectors to study the lunar environment. Many of these instruments continued to transmit data back to Earth for years after the astronauts departed, providing a treasure trove of information about the moon's interior structure, thermal history, and surface environment. The seismometers, in particular, revealed something fascinating. The moon experiences quakes, moonquakes, but they are very different from earthquakes. There are four types of moonquakes: deep moonquakes, which occur at depths of about 700 kilometers and are caused by tidal stresses from the Earth's gravity; shallow moonquakes, which occur at depths of 20 to 30 kilometers and can be surprisingly strong, reaching up to magnitude 5.5 on the Richter scale; thermal moonquakes, caused by the expansion and contraction of the surface as it heats and cools during the lunar day-night cycle; and impact-related vibrations caused by meteorites striking the surface. One of the most interesting properties of moonquakes is that they tend to last much longer than earthquakes, sometimes for over 10 minutes. On Earth, a quake of comparable magnitude might last only a few seconds. The reason for this difference is that the moon's rigid, dry crust transmits seismic waves very efficiently, with very little dampening, causing the vibrations to ring through the rock like a bell. The Apollo 12 astronauts deliberately crashed their ascent stage into the moon after returning to the command module, and the seismometers recorded the moon reverberating from the impact for nearly an hour. When this was reported, one NASA scientist famously exclaimed that the moon rang like a bell. Now let us explore something that sounds almost magical, almost too remarkable to be true, but it is absolutely, unequivocally confirmed by science. There is water on the moon. For decades, the moon was thought to be completely, utterly bone dry. The Apollo samples showed no evidence of water, and the moon's lack of atmosphere, its extreme temperatures, and its exposure to the solar wind all seemed to make the presence of water impossible. But beginning in the late 1990s and accelerating in the 2000s, a series of spacecraft missions revolutionized our understanding of lunar water. 1998, NASA's Lunar Prospector mission detected elevated levels of hydrogen at the lunar poles, suggesting the possible presence of water ice in the permanently shadowed craters near the poles. In 2009, NASA's LCROSS mission deliberately crashed a spent rocket stage into the permanently shadowed Cabeus crater near the South Pole and then flew through the resulting plume of debris, analyzing its composition. The results were definitive. The plume contained water ice. Lots of it, approximately 5.6% of the material in the plume, was water, along with other volatile compounds including methane, ammonia, carbon dioxide, and even simple organic molecules. In the same year, India's Chandrayaan-1 spacecraft, carrying a NASA instrument called the Moon Mineralogy Mapper, detected the spectral signature of water molecules, actual H2O, on the sunlit surface of the moon, particularly at high latitudes. This was a stunning discovery because it suggested that water was not confined to the polar shadows but was present, at least in trace amounts, across much of the lunar surface. The water appears to be generated by the interaction of solar wind protons with oxygen atoms in the lunar soil, and it may migrate across the surface, eventually accumulating in the cold traps at the poles. More recently, in 2020, NASA's SOFIA Observatory, a telescope mounted inside a modified Boeing 747, detected the spectral signature of water molecules on the sunlit surface of the moon near the Clavius crater, one of the largest craters visible from Earth. This confirmed that water is present even in areas exposed to direct sunlight, though in extremely small quantities, roughly equivalent to a 12-ounce bottle of water per cubic meter of lunar soil. It is not much, but the fact that it exists at all is revolutionary. The total amount of water ice at the lunar poles has been estimated at hundreds of millions of metric tons, a staggering quantity that could have profound implications for the future of human space exploration. Water is, of course, essential for human survival, but it can also be broken down into its component elements, hydrogen and oxygen, through electrolysis. The oxygen could be used for breathing. The hydrogen could be used as rocket fuel. A lunar base with access to water ice would have a self-sustaining supply of life support and propellant, dramatically reducing the cost and complexity of long-duration lunar missions and serving as a stepping stone for deeper exploration of the solar system, including missions to Mars. This is why the south pole of the moon has become the most sought-after destination for the next generation of lunar missions. NASA's Artemis program, China's Chang'e program, India's Chandrayaan program, and several private companies are all targeting the lunar South Pole for future landings. The race to reach and utilize the moon's water ice is, in many ways, the new space race of the 21st century. Let us linger for a moment on the subject of the moon's environment, because it is one of the most extreme and hostile environments in the known solar system, and understanding it is essential for any future plans to establish a human presence there. We have already discussed the moon's lack of atmosphere, its extreme temperature swings, and its exposure to solar radiation and micrometeorite bombardment. But there is another hazard that deserves special attention: cosmic radiation. On Earth, we are protected from cosmic radiation by two shields: our atmosphere and our magnetic field. The atmosphere absorbs most of the high-energy particles that rain down from space, and the magnetic field deflects many of the charged particles from the solar wind and cosmic rays. The moon has neither of these protections. Astronauts on the lunar surface are exposed to the full force of galactic cosmic rays, high-energy particles from distant supernovae and other cosmic events, and solar particle events, sudden bursts of high-energy protons from solar flares and coronal mass ejections. This radiation can damage human cells and DNA, increasing the risk of cancer and other health problems. Long-duration stays on the lunar surface will require either heavily shielded habitats or underground living quarters, perhaps in lava tubes, the remnants of ancient volcanic channels that could provide natural protection from radiation. And speaking of lava tubes, this is another fascinating feature of the lunar landscape. The moon has extensive lava tube systems, underground tunnels formed by flowing lava during the moon's volcanically active past. Some of these tubes may be enormous. Computer simulations and observations from orbiting spacecraft suggest that lunar lava tubes could be hundreds of meters wide and several kilometers long, far larger than any lava tubes found on Earth. The reduced gravity on the moon means that the roofs of these tubes can support much larger openings without collapsing. These tubes would provide natural shelter from radiation, temperature extremes, and micrometeorite impacts, making them ideal locations for future lunar habitats. Several collapsed lava tube openings, known as skylights, have been identified in orbital photographs, providing potential entry points for future exploration. As we approach the end of this first part of our journey, let us reflect on what we have learned so far. The moon is far more than a pretty light in the night sky. It is a world with a violent and dramatic origin, born from the collision of two ancient planetary bodies. It is a place of extremes, scorching heat and freezing cold, blinding sunlight and absolute darkness, deafening silence and ceaseless bombardment. It is a world without air, without weather, without sound. Its surface is a museum of cosmic history, its craters a record of billions of years of bombardment. It is slowly drifting away from us, stretching our days, weakening our tides, and one day, in the distant future, it will hang so far away in our sky that total solar eclipses will be nothing more than a memory. And yet the moon is also a world of hidden treasures. Water ice lurks in its shadowed polar craters. Vast lava tubes wind beneath its surface, waiting to shelter future explorers. Its rocks hold the secrets of our solar system's earliest days. And its steady, stabilizing gravitational presence has been quietly protecting the conditions for life on Earth for billions of years. We have walked on its surface, we have collected its rocks, we have measured its quakes and mapped its mountains, but we have only scratched the surface of what the moon has to teach us. There is so much more to discover, so much more to understand, so much more to explore, and that exploration continues in the next part of our journey. We will delve deeper into the mysteries of the moon, its phases and their influence on human culture, the strange phenomena observed on its surface, the future of lunar exploration, and the ways in which the moon continues to shape our world and our understanding of the universe. The story of the moon is far from over. In many ways, it is just beginning. Every 29.5 days, the moon completes a full cycle of phases, waxing from a slender crescent to a glorious full moon, then waning back through gibbous and crescent to the darkness of the new moon, before beginning the cycle all over again. This cycle, the synodic month, is one of the oldest units of time measurement in human history. Long before calendars were printed on paper or displayed on screens, long before clocks ticked on walls or glowed on wrists, the moon was humanity's timekeeper. Its phases were regular, predictable, and visible to everyone. Ancient civilizations around the world used the lunar cycle to track the passage of time, and many of our modern concepts of months and weeks can trace their origins back to the moon's steady, rhythmic journey through its phases. But what exactly causes the phases of the moon? It is a question that seems simple, but the answer reveals something beautiful about the geometry of our solar system. The moon does not produce its own light. It shines only because it reflects sunlight. At any given moment, exactly half of the moon's surface is illuminated by the sun, just as exactly half of the Earth is always in daylight. The phases we see from Earth are simply the result of our changing perspective on the moon's illuminated half as it orbits our planet. When the moon is between the Earth and the sun, the illuminated half faces away from us, and we see the dark side. This is the new moon. As the moon moves in its orbit, we begin to see a sliver of the illuminated half, the waxing crescent. As it continues, we see half of the illuminated side, the first quarter, then more than half, the waxing gibbous. When the moon is on the opposite side of the Earth from the sun, we see the entire illuminated half, the full moon. And then the process reverses through waning gibbous, third quarter, and waning crescent back to the new moon. It is important to note that the moon's orbital period around the Earth, the sidereal month, is approximately 27.3 days, but the synodic month, the time from one new moon to the next, is approximately 29.5 days. The difference exists because while the moon is orbiting the Earth is also orbiting the sun. By the time the moon completes one full orbit around the Earth has moved forward in its orbit around the sun, so the moon has to travel a little farther to get back to the same position relative to the sun. This extra distance adds about 2.2 days to the cycle. The lunar cycle has been woven into the fabric of human culture for millennia. The Islamic calendar is a purely lunar calendar, with each month beginning at the first sighting of the crescent moon after a new moon. The Jewish calendar and the Chinese calendar are lunisolar. They use the lunar cycle to determine months, but add extra months periodically to keep the calendar roughly aligned with the solar year. The Hindu calendar, the Buddhist calendar, the traditional calendars of many indigenous peoples around the world, all of them incorporate the lunar cycle in fundamental ways. The English word month itself derives from the Old English word moneth, which is directly related to the word moon. Even our word Monday, moon's day, preserves the ancient connection between the moon and our measurement of time. The full moon, in particular, has held a special place in human culture and mythology. In many traditions, each full moon of the year has its own name, often reflecting the seasonal changes or natural phenomena associated with that time of year. In North American tradition, for example, January's full moon is called the wolf moon, February's is the snow moon, March's is the worm moon, April's is the pink moon, September's is the harvest moon, and October's is the hunter's moon. The harvest moon, the full moon closest to the autumnal equinox, is especially notable because it rises at nearly the same time on several consecutive nights, providing extended evening light that historically allowed farmers to work longer hours bringing in their crops. The full moon has also been associated with madness and strange behavior for centuries. The word lunatic comes from the Latin luna, meaning moon, reflecting the ancient belief that the full moon could drive people insane. Even today, many police officers, hospital workers, and emergency responders will tell you that full moon nights are busier and more chaotic than other nights. However, extensive scientific studies have consistently failed to find any statistically significant correlation between the full moon and increases in crime, hospital admissions, psychiatric emergencies, accidents, or any other measure of unusual human behavior. The belief persists, likely as a result of confirmation bias, We remember the busy full moon nights and forget the quiet ones. There is, however, one area where the moon's phases do appear to have a genuine biological influence, and it involves one of the most ancient rhythms in the natural world. Many marine organisms, particularly those living in tidal and intertidal environments, have reproductive cycles that are synchronized with the lunar cycle. The most spectacular example is the mass spawning of corals on the Great Barrier Reef, which occurs once a year, a few nights after the full moon in late spring. During this event, billions of coral polyps simultaneously release their eggs and sperm into the water, creating a blizzard of reproductive material so dense that it is visible from space. The timing of this mass spawning appears to be triggered by a combination of water temperature, day length, and the lunar cycle, with the moonlight itself potentially serving as the final synchronizing cue. Other marine creatures also time their reproduction to the lunar cycle. The grunion, a small fish found along the coast of California, spawns on beaches during the highest tides following the full and new moons. The palalo worm of the South Pacific releases its reproductive segments in swarms during the last quarter moon in October or November, an event so predictable that local communities have harvested the worms as a delicacy for centuries. Even some land-dwelling animals, including certain species of dung beetles that navigate by the light of the Milky Way and the moon, appear to be influenced by the lunar cycle in their behavior. Now let us turn to one of the most visually spectacular phenomena associated with the moon, lunar eclipses. While a solar eclipse occurs when the moon passes between the Earth and the Sun, a lunar eclipse occurs when the Earth passes between the Sun and the moon, casting its shadow across the lunar surface. There are three types of lunar eclipses. A penumbral lunar eclipse occurs when the moon passes through the Earth's penumbral shadow, the outer, lighter part of the shadow, resulting in a subtle dimming of the moon that is often difficult to notice with the naked eye. A partial lunar eclipse occurs when only part of the moon enters the Earth's umbral shadow, the dark, central part, producing a dramatic effect as a dark bite appears to be taken out of the moon's face. And a total lunar eclipse occurs when the entire moon is engulfed by the Earth's umbral shadow. During a total lunar eclipse, something magical happens. The moon does not disappear entirely. Instead, it turns a deep, dusky red, a phenomenon that has earned total lunar eclipses the popular name blood moon. This red color occurs because the Earth's atmosphere bends and filters sunlight, allowing the longer red wavelengths to pass through while blocking the shorter blue wavelengths. The reddish light is refracted around the edges of the Earth and onto the moon's surface, bathing it in an eerie, coppery glow. The exact shade of red depends on the condition of Earth's atmosphere. If there has been a major volcanic eruption recently, the additional particles in the atmosphere can darken the eclipse significantly, sometimes turning the moon almost black. Total lunar eclipses have inspired fear and wonder throughout human history. Many ancient cultures interpreted the reddening of the moon as a sign of disaster, divine anger, or cosmic battle. In Norse mythology, the wolf Hati was believed to chase the moon across the sky, and a lunar eclipse was said to occur when the wolf caught and began to devour it. In Chinese tradition, a celestial dragon was thought to swallow the moon during an eclipse, and people would bang drums and make noise to frighten the dragon away. The ancient Inca believed that a jaguar was attacking the moon, and they would shake their spears at the sky and urge their dogs to howl to scare the beast off. Christopher Columbus famously used his foreknowledge of a lunar eclipse in 1504 to manipulate the indigenous Arawak people of Jamaica into providing him and his stranded crew with food and supplies by predicting the disappearance of the moon and claiming that his god was angry with them. Unlike solar eclipses, which can only be seen from a narrow path on Earth's surface, lunar eclipses are visible from anywhere on the night side of the Earth. They also last much longer. A total lunar eclipse can last for over an hour, compared to the maximum 7 minutes of totality for a solar eclipse. This makes lunar eclipses far more accessible and has ensured that they have been observed and recorded by cultures all over the world throughout history. Let us now explore some of the stranger and more mysterious phenomena that have been reported on the moon over the centuries, phenomena that have puzzled astronomers and sparked the imaginations of sky watchers for hundreds of years. Since at least the 6th century, observers have reported seeing brief, unexplained changes on the lunar surface, flashes of light, colored glows, temporary obscurations, and other transient events. These are known as transient lunar phenomena, or TLPs, and they remain one of the most intriguing unsolved puzzles in lunar science. Over 1,000 TLP reports have been catalogued over the past several centuries. Some of the most famous include a red glow observed in the crater Aristarchus by astronomers at the Lowell Observatory in 1963, and a series of bright flashes reported by Apollo mission crews in lunar orbit. The events are most commonly associated with specific locations on the moon, particularly the craters Aristarchus, Plato, and Kepler, and the edges of the Maria. Several explanations have been proposed for TLPs. One leading theory is outgassing, the release of gases from the moon's interior through cracks in the crust, possibly triggered by tidal stresses from Earth's gravity. These gases could carry dust particles that scatter sunlight, producing the observed glows and flashes. Another possibility is that some TLPs are caused by the electrostatic levitation of charged dust particles above the lunar surface, a phenomenon that has been predicted by theoretical models and may have been observed by the Surveyor landers in the 1960s. Still, other reports may be attributable to meteorite impacts, which would produce brief flashes of light as the kinetic energy of the impactor is converted to heat and light. In fact, meteorite impacts on the moon can be observed from Earth with relatively modest equipment. Amateur astronomers have recorded numerous impact flashes on the moon, particularly during meteor showers when the flux of incoming particles is elevated. NASA has operated a lunar impact monitoring program since 2005, using ground-based telescopes to systematically watch the moon's night side for the bright flashes produced by meteorite strikes. These observations help scientists understand the rate at which the moon is being bombarded and the size distribution of the impactors, which has implications for both lunar exploration and our understanding of the near-Earth space environment. Now, let us discuss something that often surprises people when they first learn about it, the fact that the moon has quakes. We touched on moonquakes briefly in the first part of our documentary, but there is much more to say about this fascinating subject. The moon is not the geologically dead world that it was once thought to be. While it lacks the active plate tectonics and volcanic eruptions that characterize the Earth, the moon is still geologically active in subtle but important ways. In addition to the deep and shallow moonquakes detected by the Apollo seismometers, recent analysis of high-resolution images from NASA's Lunar Reconnaissance Orbiter has revealed thousands of young fault scarps, steep slopes formed by the breaking and displacement of the lunar crust, scattered across the moon's surface. These fault scarps are estimated to be less than 50 million years old, and some may be much younger, perhaps only a few million years old. Their existence suggests that the moon is still contracting as its interior slowly cools, generating stresses that crack and shift the crust. The moon, it seems, is shrinking, not by much, perhaps only about 50 meters in radius over the past billion years, but enough to produce detectable geological activity. This has practical implications for future lunar exploration. Shallow moonquakes, which can reach magnitudes of up to 5.5, could pose a genuine hazard to lunar habitats and infrastructure. Understanding the distribution and frequency of these quakes will be essential for selecting safe locations for future bases and for designing structures that can withstand the occasional tremor. Let us now turn our attention to one of the most fascinating and least understood aspects of the moon, the lunar atmosphere, or more accurately, the lunar exosphere. We discussed earlier that the moon has an incredibly thin envelope of gas that barely qualifies as an atmosphere. But recent discoveries have added intriguing new details to this picture. In 2015, NASA's LADE mission, the Lunar Atmosphere and Dust Environment Explorer, spent 7 months orbiting the moon at very low altitude, directly sampling the exosphere and studying the lunar dust environment. LADE confirmed the presence of helium, neon, and argon in the exosphere and made the first direct detection of exospheric water vapor. It also studied the behavior of lunar dust, which behaves in strange and sometimes counterintuitive ways in the Moon's environment. Lunar dust is, in fact, one of the most significant challenges facing future lunar explorers. The fine particles of regolith are incredibly abrasive, much more so than terrestrial dust, because they have never been smoothed by wind or water. Each grain is a tiny, jagged fragment of broken rock, sharp enough to scratch glass and metal. The dust is also highly adhesive, clinging to spacesuits, equipment, and visors through electrostatic charge. During the Apollo missions, the astronauts found that lunar dust got into everything. It coated their suits, jammed their equipment, scratched their visors, and irritated their eyes and lungs when it was tracked back into the lunar module. Harrison Schmitt, the geologist astronaut of Apollo 17, reported symptoms similar to hay fever after exposure to lunar dust, leading to concerns about the potential long-term health effects of dust inhalation. The problem of lunar dust is not merely an inconvenience. It is a serious engineering and health challenge that must be solved before long-term human habitation of the Moon becomes practical. Researchers are currently exploring a variety of approaches, including electrostatic dust shields, specialized coatings, and advanced air filtration systems. Let us now journey beyond the human missions and explore the robotic missions that have expanded our knowledge of the Moon in the decades since the last Apollo astronaut left its surface. Because while no human has walked on the Moon since 1972, the Moon has been far from neglected. A fleet of robotic emissaries from multiple nations has visited, orbited, mapped, and studied our lunar companion with increasing sophistication and detail. The Soviet Union continued its robotic lunar program well after the Apollo era. The Luna program deployed several successful missions in the 1970s, including Luna 16, 20, and 24, which were robotic sample return missions that brought small quantities of lunar soil back to Earth without the need for human astronauts. The Soviets also deployed two Lunokhod rovers, Lunokhod 1 in 1970 and Lunokhod 2 in 1973, remote-controlled robotic vehicles that roamed the lunar surface for months, taking photographs, analyzing soil, and conducting scientific experiments. Lunokhod 2, in particular, set a distance record for off-Earth driving that stood for over 40 years, covering approximately 39 kilometers across the lunar surface. After the Soviet program wound down in the mid-1970s, the Moon entered a period of relative neglect by the spacefaring nations. For nearly 2 decades, no new missions were sent, but beginning in the 1990s, interest in the Moon revived dramatically. In 1994, the joint NASA Department of Defense mission Clementine became the first American spacecraft to orbit the Moon in over 2 decades. Clementine produced the first complete, high-resolution digital maps of the lunar surface and made the first tentative detection of water ice at the South Pole. This was followed in 1998 by Lunar Prospector, which confirmed the presence of hydrogen at the poles and produced detailed maps of the Moon's surface composition and gravitational field. The 2000s saw a renaissance in lunar exploration, with multiple nations sending spacecraft to the Moon for the first time. The European Space Agency launched SMART 1 in 2003, which orbited the Moon for nearly 3 years, testing new propulsion technology and conducting scientific observations. Japan launched Selene, also known as Kaguya, in 2007, producing stunning high-definition video of the lunar surface and making important scientific measurements of the Moon's gravity field and surface composition. China entered the lunar arena with Chang'e 1 in 2007 and Chang'e 2 in 2010, both orbital missions that mapped the Moon in unprecedented detail. India's Chandrayaan-1 mission, launched in 2008, made headlines worldwide when its Moon Mineralogy Mapper instrument detected water molecules on the sunlit lunar surface, one of the most significant lunar discoveries of the 21st century. NASA's Lunar Reconnaissance Orbiter, launched in 2009, has become one of the most productive and long-lived lunar missions in history. Operating continuously for over 15 years, LRO has photographed the entire lunar surface at resolutions as fine as 50 centimeters per pixel, revealing details as small as the tracks left by the Apollo astronauts and the equipment they left behind. LRO has also produced detailed topographic maps, temperature maps, and hydrogen concentration maps that have transformed our understanding of the lunar surface. China's Chang'e program has been particularly ambitious and successful. Chang'e 3, launched in 2013, carried the Yudu rover to the lunar surface, the first soft landing on the moon in 37 years. Chang'e 4 in January 2019 achieved a historic first by landing on the far side of the moon, in the von Karman crater within the South Pole Aitken Basin. This required the deployment of a relay satellite, Quekeo, in a special halo orbit beyond the moon to maintain communication with Earth, since the far side is always facing away from our planet and direct radio communication is impossible. Chang'e 5, launched in November 2020, successfully collected approximately 1.7 kilograms of lunar samples and returned them to Earth, the first lunar sample return mission in 44 years. Analysis of these samples has already yielded important discoveries, including evidence that volcanic activity on the moon may have continued until as recently as 2 billion years ago, much more recently than previously thought. India's Chandrayaan-3 mission, in August 2023, successfully soft-landed the Vikram lander and Pragyan rover near the lunar South Pole, making India the fourth country to achieve a soft landing on the moon and the first to land near the South Polar region. This achievement was celebrated worldwide and marked a significant milestone in the growing international effort to explore the moon's polar regions. The future of lunar exploration promises to be even more exciting. NASA's Artemis program aims to return astronauts to the moon, including the first woman and the first person of color to walk on the lunar surface. The program plans to establish a sustainable presence on and around the moon, including the Lunar Gateway, a space station in lunar orbit that will serve as a staging point for missions to the surface and beyond. China has announced plans for a robotic research station at the lunar South Pole, with ambitions for crewed missions to follow. The European Space Agency, Japan, South Korea, and several private companies are all planning or developing lunar missions. The commercial space sector, in particular, has emerged as a major player in the new era of lunar exploration. Companies like SpaceX, Blue Origin, Intuitive Machines, Astrobotic, and iSpace are developing lunar landers and transportation systems that promise to dramatically reduce the cost of reaching the moon and open it up to a much wider range of scientific, commercial, and even touristic activities. In February 2024, Intuitive Machines' Odysseus lander became the first commercially built spacecraft to achieve a soft landing on the moon, marking the beginning of a new chapter in humanity's relationship with its nearest celestial neighbor. Now let us explore a question that has fascinated humanity for centuries, and that remains the subject of intense scientific investigation today. Is there or was there ever life on the moon? The short answer, as far as we currently know, is no. The moon's surface environment is extraordinarily hostile to life as we understand it. The lack of atmosphere, the extreme temperature swings, the intense radiation, and the absence of liquid water on the surface all combine to make the moon one of the least hospitable places in the solar system for biological organisms. However, the question is more nuanced than it might appear at first glance. The discovery of water ice at the poles and the detection of water molecules on the sunlit surface have raised intriguing questions about whether microbial life could potentially survive in some sheltered niche, perhaps deep within the regolith, where temperatures are more stable and radiation is reduced. In 2019, The Israeli Bereshit lander crashed on the moon while carrying a payload that included tardigrades, microscopic animals known for their extraordinary ability to survive extreme conditions, including the vacuum of space, intense radiation, and extreme temperatures. Whether any of the tardigrades survived the crash and are now sitting on the lunar surface in a state of suspended animation is unknown, but the incident raised important questions about planetary protection, the practice of preventing biological contamination of other worlds. There is also the fascinating question of whether the moon could have harbored life in its distant past. Some scientists have speculated that during brief periods in the moon's early history, perhaps around 4 billion years ago, volcanic outgassing may have produced a temporary, thin atmosphere and liquid water may have existed on the surface for short periods. If so, the conditions for life, however fleeting, may have existed. This remains highly speculative, but it is a tantalizing thought. Let us now delve into a topic that connects the moon to the deepest traditions of human culture, the role of the moon in mythology, religion, art, and literature. The moon has been a central figure in the mythologies of virtually every human civilization. In ancient Mesopotamia, the moon god Sin was one of the most important deities in the Sumerian and Babylonian pantheons, the father of the sun god Shamash and the goddess Ishtar. In ancient Egypt, the moon was associated with the god Thoth, the deity of wisdom, writing, and magic, and with the god Khonsu, whose name means traveler, reflecting the moon's journey across the sky. In ancient Greece, the moon was personified as the goddess Selene, who drove her silver chariot across the night sky, and was also associated with Artemis, the goddess of the hunt, and Hecate, the goddess of magic and crossroads. In Roman mythology, the moon goddess was Diana, the twin sister of Apollo, a name that would centuries later be given to the program that sent humans to the moon. In Hindu mythology, Chandra is the god of the moon, riding his chariot pulled by 10 white horses across the night sky. The waxing and waning of the moon is explained by a curse. Chandra was cursed to gradually waste away, but the curse was modified so that he would also gradually return to fullness, creating the eternal cycle of lunar phases. In Chinese mythology, Chang'e is the goddess of the moon, who drank an elixir of immortality and floated up to the moon, where she has lived ever since. The Chinese lunar exploration program is named in her honor. In Japanese mythology, the moon is associated with Tsukuyomi, the god of the night and the moon, who was banished to the sky by the sun goddess Amaterasu. In many indigenous cultures of the Americas, the moon is often depicted as a male figure complementing a female sun, and lunar myths frequently involve themes of transformation, rebirth, and the cyclical nature of time. The moon has also played a central role in the arts. In music, from Beethoven's Moonlight Sonata to Debussy's Clair de Lune to Frank Sinatra's Fly Me to the Moon has inspired some of the most beloved compositions in Western music. In literature, the moon has appeared in works ranging from Lucian of Samosata's True History in the 2nd century, one of the earliest known works of science fiction, which includes A Voyage to the Moon, to Jules Verne's From the Earth to the Moon in 1865, to H.G. Wells' The First Men in the Moon in 1901. In visual art, the moon has been depicted countless times, from ancient cave paintings to Van Gogh's Starry Night to the iconic Earthrise photograph taken by the Apollo 8 astronauts. The moon has also profoundly influenced language and the way we think. Beyond lunatic and Monday, the moon has given us words and phrases like moonshine, moonlit, honeymoon, moonlighting, and once in a blue moon. A blue moon, incidentally, is the popular name given to the second full moon in a calendar month, an event that occurs approximately once every 2.5 years. The phrase, once in a blue moon, has come to mean something rare and unusual, which is fitting, since the phenomenon itself is relatively uncommon. But there is an actual optical phenomenon that can make the moon appear blue. When large quantities of particles of a specific size, roughly 1 micrometer in diameter, are present in Earth's atmosphere, they can scatter red light more than blue light, causing the moon to take on a distinctly bluish tinge. This can occur after major volcanic eruptions or large forest fires. After the eruption of Krakatoa in 1883, blue moons were reported for nearly 2 years as volcanic ash circled the globe. Let us now address a question that looms large in any discussion of the moon's future: who owns the moon? Can any nation or corporation claim sovereignty over lunar territory? Can individuals buy land on the moon? The legal status of the moon is governed primarily by the Outer Space Treaty of 1967, which has been ratified by over 100 nations, including all of the major space-faring countries. The treaty declares that outer space, including the moon and other celestial bodies, is not subject to national appropriation by claim of sovereignty, by means of use or occupation, or by any other means. In other words, no country can claim the moon or any part of it as its territory. The treaty also states that the exploration and use of outer space shall be carried out for the benefit of all countries, and that celestial bodies shall be used exclusively for peaceful purposes. A later agreement, the Moon Treaty of 1979, attempted to go further by declaring the moon and its resources to be the common heritage of mankind, and calling for the establishment of an international regime to govern the exploitation of lunar resources. However, the Moon Treaty has been ratified by only a handful of countries and has not been signed by any of the major space-faring nations, including the United States, Russia, and China. As a result, it has had little practical effect. The question of lunar resource rights has become increasingly urgent as the prospect of mining water ice and other resources on the moon has grown more realistic. In 2015, the United States passed the Commercial Space Launch Competitiveness Act, which grants American citizens the right to own and sell resources extracted from celestial bodies, while explicitly disclaiming any sovereignty claim over the celestial body itself. This is analogous to fishing rights in international waters. You can catch the fish, but you do not own the ocean. Several other countries have enacted similar legislation, but the broader international legal framework for lunar resource utilization remains a work in progress. As for those companies that claim to sell plots of land on the moon, they are, unfortunately, selling nothing of value. No individual or company has any legal authority to sell lunar real estate, and any deed to moon land is nothing more than a novelty item. The moon belongs to no one, or perhaps more accurately, it belongs to everyone. Now let us explore some of the more surprising and lesser-known facts about the moon, the kinds of details that make you stop and say, "Really?" when you hear them for the first time. Here is one: the moon has a smell. As we mentioned in the first part of our documentary, the Apollo astronauts reported that lunar dust had a distinctive odor when they brought it back into the lunar module. They described it as similar to spent gunpowder or the smell of a fired capped gun. This smell is thought to be produced by a chemical reaction between the reactive, solar wind-altered minerals in the lunar soil and the moist air inside the spacecraft. On the moon's surface in the vacuum, the dust has no smell, but the moment it encounters air and moisture, the chemical reaction produces that characteristic burnt odor. Here's another: there are mirrors on the moon. The Apollo 11, 14, and 15 missions each deployed a lunar laser-ranging retroreflector, a panel of special corner cube reflectors designed to reflect laser light directly back to its source. Scientists on Earth regularly fire powerful lasers at these reflectors and measure the time it takes for the light to bounce back. By measuring this round-trip time with extraordinary precision, scientists can determine the distance to the moon to within a few millimeters. These ongoing measurements have confirmed that the moon is receding from Earth at 3.8 centimeters per year, have provided the most precise tests of certain aspects of general relativity, and have revealed subtle details about the moon's orbit and internal structure. The retroreflectors require no power and have no moving parts, so they will continue to function essentially forever. They are among the most enduring legacies of the Apollo program. Here is yet another surprising fact: there are human-made objects on the moon from countries that have never sent humans there. The Soviet Union's Lunar rovers are still sitting on the surface where they came to rest decades ago. Crashed or decommissioned spacecraft from the United States, the Soviet Union, Japan, India, Israel, China, the European Space Agency, and several private companies now litter the lunar landscape. In total, there are estimated to be over 100 human-made objects on the moon, ranging from spent rocket stages to scientific instruments to personal items left behind by astronauts, including family photographs, religious texts, memorial items, and most famously, 6 American flags. The fate of those flags is a question that has intrigued many people. Have they survived? Are they still standing? Photographs taken by the Lunar Reconnaissance Orbiter have confirmed that at least 5 of the 6 Apollo flags are still standing. The flag planted by Apollo 11 is believed to have been knocked over by the exhaust blast when the ascent stage lifted off, as Buzz Aldrin reported seeing it fall. However, scientists believe that the flags have almost certainly been bleached completely white by decades of unfiltered ultraviolet radiation from the sun. The nylon fabric, never designed to withstand the harsh lunar environment, has likely become extremely brittle and may have partially disintegrated. The stars and stripes that once represented one of humanity's greatest achievements now fly, if they fly at all, as blank white banners, which in a way is oddly appropriate, since a white flag is a universal symbol of peace, and the plaque left on the moon by Apollo 11 declared that we came in peace for all mankind. Let us consider another remarkable aspect of the moon that we have not yet fully explored, the moon's influence on Earth's geology. We have discussed the tides and the stabilization of Earth's axial tilt, but the moon's influence goes even deeper than that, literally. Some researchers have found correlations between the lunar tidal cycle and the frequency of certain types of earthquakes, particularly shallow, low-magnitude tremors in volcanic regions. The idea is that the same tidal forces that raise and lower the oceans also deform the solid Earth, flexing the crust by a few centimeters and potentially triggering the release of built-up tectonic stress in faults and volcanic systems. The evidence for this connection remains the subject of scientific debate, but several studies have reported statistically significant correlations between the timing of large earthquakes and the phase of the tidal cycle. The moon may also have played a role in maintaining Earth's plate tectonics over geological time. Some scientists have hypothesized that the tidal heating generated by the moon's gravitational pull on the Earth's interior, similar to the tidal heating that drives volcanic activity on Jupiter's moon Io, may have helped to keep the Earth's mantle warm and viscous enough to sustain the convection currents that drive plate tectonics. Without plate tectonics, Earth's surface would not be recycled, carbon dioxide would not be drawn out of the atmosphere through weathering and subduction, and the planet's long-term climate regulation system would break down. If this hypothesis is correct, the moon may be indirectly responsible for maintaining the geological processes that keep Earth habitable. Now let us talk about something that connects the moon to the cutting edge of modern astronomy, the idea of placing astronomical observatories on the moon. The far side of the moon is one of the most radio-quiet locations in the inner solar system. Because it always faces away from Earth, it is shielded from the constant radio noise generated by human civilization, television broadcasts, cell phone signals, radar systems, satellite communications, and all the other electromagnetic clutter that fills Earth's radio environment. This makes the far side of the moon an ideal location for radio telescopes, which could observe the universe at frequencies that are impossible to detect from Earth's surface. One particularly exciting possibility is using a far-side radio telescope to detect signals from the cosmic dark ages, the period between approximately 400,000 and 200 million years after the Big Bang, before the first stars formed. During this era, the universe was filled with neutral hydrogen gas, which emitted radio waves at a characteristic frequency. These signals have been redshifted by the expansion of the universe to very low frequencies, frequencies that are completely blocked by Earth's ionosphere and drowned out by terrestrial radio interference. A radio telescope on the far side of the moon could potentially detect these signals and give us our first direct observations of the universe before the first stars ignited, a window into a period of cosmic history that is currently completely invisible to us. NASA has funded preliminary studies of such a telescope, and it remains one of the most compelling scientific motivations for establishing a permanent presence on the moon. The moon could also serve as a platform for optical and infrared telescopes. The lack of atmosphere means there is no atmospheric distortion, the bane of ground-based astronomers on Earth, and the long lunar night provides 2 weeks of continuous darkness for uninterrupted observations. The extreme cold at the polar craters would be ideal for infrared telescopes, which must be cooled to very low temperatures to function properly. The stable, solid surface of the moon would also be advantageous for interferometric arrays, networks of telescopes that work together to achieve the resolving power of a single telescope with a much larger aperture. As we approach the end of our documentary, let us take a step back and consider the moon in the broadest possible context, its place in the story of our solar system, our planet, and our species. The moon is the only world beyond Earth that human beings have ever visited. 12 people have walked on its surface. Hundreds of robotic spacecraft have orbited it, landed on it, or impacted it. We have brought pieces of it back to our laboratories and studied them under microscopes. We have mapped its surface to a resolution of centimeters. We have listened to its quakes, measured its magnetic whispers, and discovered water hiding in its darkest shadows. And yet, in so many ways, the moon remains a mystery. We are still debating the exact mechanism of its formation. We do not fully understand the origin of its dramatic near-far asymmetry. We have not yet explored its lava tubes or drilled into its subsurface. We have not determined the full extent of its water-ice deposits. We have not yet built the telescopes that could use the far side as a platform for peering into the cosmic dark ages. The moon is close enough that we can see it with our naked eyes, close enough that we have walked upon it, and yet it still holds secrets that will take decades, perhaps centuries, to fully unravel. The moon has been a constant presence in the story of our species. It was there when the first hominids looked up from the African savanna and wondered about the world beyond the firelight. It was there when the first civilizations arose along the Nile, the Tigris, the Euphrates, and the Indus. It was there when Galileo pointed his telescope at the sky and saw mountains and craters where the ancients had seen gods and legends. It was there when Neil Armstrong stepped off the ladder of the lunar module and pressed his boot into the fine, gray powder. And it will be there long after every human being alive today has returned to dust. The moon has shaped our planet in ways that most people never consider. Its gravity stabilizes our axial tilt, giving us the predictable seasons that make complex life possible. Its tidal pull drives the ocean currents, shapes our coastlines, and may have played a role in the emergence of life from the sea onto the land. Its presence slows the Earth's rotation, gradually lengthening our days. Its gravitational partnership has helped make Earth the extraordinary, life-bearing world it is today. The moon has shaped our culture in ways that are woven into the very fabric of civilization. It gave us our first calendar. It gave us our concept of the month. It gave us holidays and festivals, myths and legends, symbols and metaphors. The crescent moon appears on the flags of nations. The full moon marks sacred days in religions around the world. The moon is embedded in our language, our art, our music, our dreams, and the moon has shaped our destiny as a species. It was the moon that drew us out into space, that challenged us to develop the technologies of rocketry and spaceflight, that inspired one of the greatest cooperative scientific and engineering efforts in human history. The Apollo program did not merely put footprints on the moon, it gave humanity a new perspective on itself. The photographs of Earth taken from the moon, that tiny, fragile blue marble hanging in the blackness of space, changed the way we see our world and our place in the cosmos. For the first time, we could see our home from the outside, and the view was both beautiful and humbling. Now, as we stand at the beginning of a new era of lunar exploration, the moon offers us something more. It offers us a stepping stone, a place to learn how to live and work on another world, to develop the technologies and techniques that will one day carry us to Mars and beyond. The water ice at the poles could fuel rockets that carry us deeper into the solar system. The lava tubes beneath the surface could shelter the first permanent human settlements beyond Earth. The radio quiet far side could give us telescopes capable of seeing farther back in time than any instrument on Earth. The moon is not just our past, it is our future. There is a beautiful symmetry in this. 4.5 billion years ago, a catastrophic collision gave birth to the moon and reshaped the destiny of the Earth. Now, billions of years later, the descendants of that reshaped Earth are returning to the moon, reaching back across time and space to the very body that made their existence possible. We are, in a sense, coming home to a home we never knew we had. The moon is always there. It rises and sets, waxes and wanes, silver and silent, patient and eternal. It has watched over us since before we were us. It has pulled our oceans, steadied our spin, lit our nights, and fired our imaginations. It has been our mirror, our muse, our companion, our challenge, and our destination. And it waits still. Look up tonight, find the moon. Whether it is a slender crescent hanging low in the western sky at dusk, or a full, blazing disk riding high overhead at midnight, or even if it is hidden in the shadow of a new moon and invisible to your eyes, it is there. It is always there. And now, armed with the knowledge you have gained from this documentary, you will never look at it the same way again. You will see not just a light in the sky, but a world born in fire, sculpted by time, and waiting with infinite patience for the day when we return to its surface and begin the next chapter of the greatest story ever told. The story of the moon, the story of the Earth, the story of us. Thank you for joining us on this extraordinary journey through 100 facts about the moon. We hope that this documentary has deepened your understanding, expanded your wonder, and inspired you to keep looking up. The universe is vast and full of mysteries, and the moon, our closest, most faithful companion, is the perfect place to begin exploring them. If you have enjoyed this documentary, please subscribe to the channel, share this video with someone who loves the cosmos, and leave a comment below telling us your favorite fact about the moon. We will see you in the next video. Until then, keep looking up. The moon will be waiting.